All right, welcome back, everybody. I hope you had a nice, relaxing weekend. And today we're going to get going on learning targets 5 and 6. So, learning target 5 is I can create a graph to represent scientific data, and I can interpret a line graph. Learning target 6 is I can write a conclusion to explain results. So, your to do list for today. Step 1 is to watch this video and take notes. Step 2 and 3 are combined just like on Friday. So you're going to be watching a graphing information video made by Miss Loso. And at the same time, you are going to go back and access your data table from your science folder. And you're going to use that data table from those Google Sheets to create a graph. So Miss Loso will take you through it step by step. So make sure that you're following along. And now today, let's start out with our daily review. So remember to be writing this down in your notebook. So our daily review is going to be writing true or false after each of these statements. So take a moment, pause the video, and write down your answers. All right, so let's go over these answers now. So number 1, a quantitative observation does not include a number. That statement is false. Quantitative observations do include numbers. Number 2, a qualitative observation describes the characteristic traits of an object. That statement is true. Number 3, the dependent variable is the factor that scientists change on purpose. False. That is the independent variable. Our dependent variable is what we are measuring and observing. Number 4, there is no need to have more than one trial in a scientific experiment. That is false. You want many, many trials. And then number 5, experimental procedures should be clear and easy to understand with enough detail that anyone could follow and get the same results. That is true. So moving forward with today, we're going to be talking about graphing and different types of graphs. So the first type of graph we are going to talk about is a bar graph. This is used when we're trying to compare several individual items or events. And so if you're looking at this bar graph here, you can see that on our x-axis here, we're looking at the months of the year. And on our y-axis, we're going to be looking at the number of buses manufactured. And so you can see that on their x-axis, they labeled their months of the year, and on their y, the number of buses manufactured. And so you're able to see from this bar graph that as the months go on, more buses were being manufactured. The second type of graph we're going to talk about is a pie graph. And pie graphs are used for displaying data that are in percentages. And percentages are used to display how much of the pie each part represents. So when we're looking at this pie graph here for favorite type of movie, they surveyed 20 people. And so we were able to see what percent of those 20 people had these favorite types of movies. So for action, it was 5 out of the 20. And so that's 25%. And for comedy, you can see that 4 of the 20 people, that was their favorite, so that's 20%. In sci-fi, that was another 20%. Drama, that was 5%. And romance was 30%. So now, the next type of graph we're going to talk about is a line graph. And so a line graph shows the relationship between two variables and allows for estimation of in-between points. And so our first example here is we can look at wildlife population. And so you can see we're going to be looking at bears, dolphins, and whales. And on our y-axis here, you can see that is the population amount. And so we're able to see how this is changing over years for each of these species. And then you can look at pumpkin spice and gingerbread items, see more seasonal fluctuation in demand than peppermint. And so again, we can see pumpkin spice, gingerbread, peppermint, and we're able to see the seasonal trend. and throughout the weeks. So let's think back to Friday. What kind of graph should we use for the data table that you made? And so the type of graph that you are going to be making is going to be a line graph. That is going to be the best way to see the relationship between the amount of fertilizer and our plant height. So now let's talk about the components of a graph. So number one, you need your axes to be labeled. And so your independent variable goes on the x-axis, and so that's our horizontal. And then the dependent variable goes on the y-axis. That's our vertical axis. You should always include units on your axes. One exception to our rule is that time will always go on the x-axis. And so if you're ever using something with time, that will always go on the x-axis there. So I want you to take a moment and think, what are the independent and dependent variables in our scenario from Friday? So our independent variable was the amount of fertilizer. That's what we were changing. And so that's going to go on our x-axis. And then our dependent variable will go on our y-axis, and that was the average plant height. So another component of your graph needs to be the title. You always want to title your graph so when people are looking at it, they know what your graph is about. And so a form that you should use is y-axis title versus your x-axis title for blank. And so that's a general form that you can use. And now scaling the axes. That's our third component. You want to put scales on both the x and the y-axis. The scale should be evenly spaced out so that each box or line of the grid is equal to the same amount. And so common ways are counting by 5s or 10s or 20s or 50s, just depending on what you are looking at. You don't want to scale it 1, 2, and then all of a sudden jump to 17, and then to 23, and then to 35. It should be evenly spaced out. So let's take a look here. So as we can see, we have our title, average plant height versus amount of fertilizer. And so you can see here, this is properly set up on our x-axis. We have our title and our units for it, our amount of fertilizer measured in grams, and it's scaled by 5s. And then we have our average plant height, which again has our units, centimeters. Now, what is this graph missing? This graph is now missing having it scaled here. And so another way we could scale it is we could do it exactly by 5s again. So we start at 0, 5, 10, 15, 20, and so on. That could be one way to scale this graph. Now, a fourth component is plotting the data. So you want to plot your data points on the graph. And so you know for 5 grams of fertilizer, it was this number. And so you're going to plot that point on the graph. Once you have your data points plotted, you can draw a smooth trend line through the points. It does not need to connect all the points, but it should be a line that shows the pattern and ignores points that have resulted from errors. So let's take a look. A linear trend line here, you can see it's showing that general trend. It's a nice straight line. Is it connecting every single data point? No, but it's following the general trend of our data points. Another type of trend line is a curved trend line that you can see here. And this tends to go well with data that is kind of starting to increase exponentially, or it has that sharp curve, versus here, it's a pretty general, our data points are pretty straight going through. But you can see here that curved trend line gives a better description of our data. So last slide for today is writing conclusion. A conclusion summarizes what happened in your experiment, and it answers these questions. What question were you trying to answer? So that's including the independent variable and the dependent variable. What was the answer to your question? How does your data support your answer? And if your teacher watched every step of your experiment, what are 2 things that they would say you could do better on? And after doing your experiment, what is one new question that you have? And so I really want you, after you make your graph, to think about some of these questions. What were we trying to answer? What ended up being the answer? How does our data support our answer? And if we actually carried out this experiment, what are 2 things that you could say you do better on? And after the experiment, what's a question that you now have? So after this, remember to hit mark as done. Make sure you wrote down some good notes, and then move on to steps 2 and 3. And as always, let me know if you have any questions.